Let's see. Right. Okay. Get out that sheet, number 8. Let's see. Okay. Yeah, okay. So we haven't really done that yet. Well, y'all did it. Okay, let's see. Okay, now most of you finished this and we hadn't even done it yet. Hadn't even had the notes on it. But before we look at the answers on that, I need to do this for Amber at home, because the numbers are not the same on these worksheets. So on chapter 5, this one where it has just problems, chapter 5, 1 through 6, that's page 1. And then the adding positive and negative numbers is page 2. Subtracting is page 3. Multiplying is page 4. Okay. Dividing is page 5. Okay, and then this was just simplifying different things. Adding, subtracting, multiplying, dividing, that was page 6. And then 7, we had expressing these as a decimal, classifying as rational or irrational, repeating, terminating, all that stuff. That's 7. And then we're on page 8 right now. Okay, and these are the ones that you're supposed to finish, like 1 through 17. Okay, and so let's see. I think we'd already checked those, right, down through there. And then we were rationalizing the denominator. So let's look at the answers on the rationalizing the denominator part. Okay, we had 1 over the square root of 3. And they never want the radical in the denominator. So you multiply by whatever the denominator is, put it over itself, which is the same thing as multiplying by 1. So 1 times square root of 3 is square root of 3. 3 times 3 is 9. Square root of 9 is a 3. Okay, and then this one is square root of 3. This one's square root of 30 over 10. 5 on to square root of 7 over 7, and then square root of 5. Okay, any of these that you need to see worked out?
Can you show me 16? That one gave me trouble last week.
Be glad to. Okay, 16 is the square root of 50 over the square root of 14. Okay, I'm assuming you did this. Okay, all right, and then 50 times 14, is that 700?
Yes.
And then this one just gives you a 14. I'm sure you figured out by now, whatever the denominator is, you take the square root of it, you're just removing the radical sign, so you get a 14. Okay, and then this one is what, 100 times 7 over 14. So the square root of 100 is 10. So that comes out, and then you have square root of 7 over 14. Then you have to simplify 10 14s. So 2 are going to 10 5 times, 2 are going to 14 7 times, and then you have that left.
The only thing I didn't do, I got to 10 radical 7 over 14.
Just didn't simplify it.
Can you show me how you did that? So you just divided.
That's just like if you have a fraction of 10 14s.
Okay, gotcha.
So 2 are going to 10 5 times, 2 are going to 14 7 times. You're just simplifying that part right there because it's a fraction. Okay. Any other questions? Okay, back on this page over here. Any questions on any of those right there? Okay, now before we go to the next part, which you have already done, okay, let's look at what we have done. We talked about prime numbers, okay, and those are numbers that are only divisible by itself in 1. So it's 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, so forth and so on. Then you have to decide if things are prime or composite, and so we did like factor trees. If you had something like 36, some people would see that as 6 times 6. Okay, break that down into 2 times 3, and that down into 2 times 3. You've got 2 squared times 3 squared. Other people would have seen this as like 4 times 9 or something like that. It doesn't matter how you start, but when you get to prime numbers, you're at the end. Okay. All right.
Can I ask you something? I'm sorry, you asked.
That's fine.
I'm about to ask something that might sound like I'm an idiot. You know how we part of what we did, I think it was the last test, is figure out how many numbers make like a square or whatever. And like it turns out it's the number times itself. So when you say 2 squared and 3 squared, it's basically the same thing. It literally means
yes.
It's a square.
Yeah, it is a square.
That makes sense to me.
Okay. All right, then the next thing on page 1 was evaluating these different expressions right here. Now, in order to do that, we have to do our order of operations. And we said to use please excuse my dear Aunt Sally, okay, to help us to remember what to do first. P stands for either parentheses or do whatever the innermost grouping symbol is first. You can even have braces outside of that, but you do whatever is inside first. So that's P stands for parentheses. E stands for exponents. So if you've got an exponent in there, you have to do that next. Then you have multiplication or division in order from left to right. Okay. Addition and subtraction in order from left to right. Okay. So if we have one, let's see. Let's go on over to, let's see, page 6. Okay. If we have something like number 8D. This is on page 6, number 8D. We have a negative 19 minus negative 3 minus a negative 2, and then parentheses like this. Okay. All right, so what you have to do is what is in the innermost grouping symbol first. And then you look in there to see if there's anything to do. There's not. But if you put this down, okay, you have a negative 3 minus a negative 2. On subtraction, you change the sign of the second number and add, which means go back to your adding rules. Okay, so what do you get when you have a negative 3 and a positive 2? Negative 1. Okay. Then you have negative 19 minus a negative 1. Subtraction, change the sign, and add. Final answer, negative 18. A negative 19 plus a positive 1 is a negative 18. Now, it's kind of hard at this stage of the game to go back and do a million of those. This is something that, like in about the 8th or 9th grade, you figured out how to do adding and subtracting and multiplying, dividing, sign numbers. But what we've been doing now is just reviewing some of those things. Okay, all right, so that was page 6. All right, then on page 7, we did express as a decimal. So if you have something like 3/5, okay, you can use your calculator and do 3 divided by 5, okay, or you can actually divide it yourself, okay, and so you get 6/10. Now this is a terminating decimal. It ends, it does not repeat, it does not keep on going, anything. Okay, Now, if you have classify as rational or irrational, okay, now this sometimes gets to be a problem, rational and irrational. Now, a way to help you remember this is when you think about the chart that we did. The one in the middle is the natural numbers. The natural numbers are the counting numbers. It's natural to count with 1, 2, 3, and so on. Natural, whole, what do we add? 0. Whole, we add the O. Okay. Next is integers. What do we add? Okay. We add the negatives. So you got -1, -2, and so on. 1, 2, 3, and so on. Okay. Natural, whole, integers, rational. Okay. The rational numbers, you add the fractions, okay, and the decimals, things that end or repeat. Then over here you got the irrational numbers. That's square root of 2, pi, things like that, things that neither end nor repeat. All of these numbers are called the real numbers. That's all numbers that we're going to talk about in this class. Okay, so when you're trying to decide on rational, irrational, this might help you. Rational are fractions and decimals and all these other numbers in between. But the irrational, they're separate. Radical 2 and pi, things that neither end nor repeat. Okay. Now, so at the bottom of page 7, you had things like 2/5. Okay. That's 0.4 or 4/10. Okay, it is a terminating decimal. It does not keep on going. Okay, 1/3 comes out to be 0.3333333. So it is repeating. Okay, so it is is a repeating decimal. Square root of 7. Okay, that comes out 2.645751311. It will never repeat the same bunch of numbers at all. So it is non-terminating. It will never end. Okay, and it will never repeat. Okay, square root of 16. Okay, that is a 4. It terminates. Okay, 5/9 comes out to 0.555555. So it is a repeating decimal. Square root of 77. Okay, and it's non-terminating, non-repeating, I think. Okay, because your calculator won't take it out as far as you need to on that. Okay, now then on page 8 we did simplifying different radicals. Okay, now when it says simplify, that means don't use your calculator. Okay, so we look for perfect squares. Now perfect squares are things like square root of 4, square root of 9, square root of 16, square root of 25, square root of 36. Things that you can find a number times itself that will equal that. So we are looking for these perfect squares inside this number. If we broke it down into 2 times 10, that doesn't help you at all. There's no perfect square there. It's a way to break it down, but it wouldn't help you. So if you use 4 times 5, 4 is a perfect square. So the square root of 4 is a 2. You bring it out, put it right there, and then you put down what's left, okay, which is a 5. Okay, so that would be our answer on that one. Okay, if we did one like square root of 72, okay. Now, if you think of things like 9 times 8 is one way to break it down, okay, and 9 is a perfect square, okay, so you could do that one. Square root of 9 is a 3, bring it out, so it's here, it's no longer there, so you have a 3 onto the square root of 8. Now, when you get to that stage, a lot of people think, well, I'm finished, but you have to break 8 down into 4 times 2. So square root of 4 is a 2, and then if you have a number here, you multiply them together. Okay, so 3 times 2 is 6 onto radical 2. Okay, then we added these things. We did like 2 onto the square root of 5 plus a 3 onto the square root of 5 gives you a 5 onto the square root of 5. Because if these two things are alike, you can add them together. You can also subtract them, so forth and so on. Now, we also did things like the square root of 3 times the square root of 6. If they're pushed together, then you can multiply them, square root of 18. Break 18 down into 9 times 2. So that gives you a 3, and that's what's left over right there. Okay. Then we had things like square root of 125 over the square root of 5. Okay. If you break 125 down into what? 25 times 5 over square root of 5. Okay. You could do it like this first, or you could remove your radical out of the denominator first. I probably would have done that. Okay, but anyway, here's a 5 onto the square root of 5, and then you've got a square root of 5 down here. Now, they don't ever like your radical symbol in the denominator. So you multiply that, which is the same thing as multiplying by 1. So this gives you a 5 and square root of 25. And this gives you the square root of 25. And so on the top, that's a 5. On the bottom, the square root of 25 is a 5. And so you end up with a 5. Now, there's about a dozen different ways to work this one. A lot of people, and mostly I would too, I would remove that out of the denominator first before I started doing any of that. But I just want to show you how, as long as you don't make any mistakes, you can keep on going and do it, however you want to do it. Okay, the next part is rationalizing the denominator. Okay, so if you did like 1 over the square root of 3, you take the square root of 3 over the square root of 3. That gives you a square root of 3 here. This is square root of 9, which is a 3. And so that's your answer there. If you have the square root of 3 over the square root of 10, you multiply by the square root of 10. Okay, so 3 on the square root of 10. 10 times 10 is 100. Square root of 100 is a 10. And this can't simplify, so that's your answer. Okay, so those are the types of problems that we were working the other day before we left here. All right, now let's see what we got to do. Okay. Let's see. All right. The next part of this has to do with properties. Okay, and most of you had already done the commutative and the associative, and so you did that. I think you did that right. Okay, the first one was commutative. 3 plus 2 equals 2 plus 3. Commutative, you switch. This one, 2 times 3 plus 5 equals 2 times 3 plus 2 times 5, and that one is the distributive property. Okay, next one, 3 times 4 plus 7 equals 12 plus 21. And that's distributive. They already multiplied it out. 3 times 4 is 12, 3 times 7 is 21. This one, 3 plus 2 plus 7 equals 3 plus 2 plus 7. Okay, they're all in the same order, 3, 2, 7, 3, 2, 7. So it was regrouping or associative. Any questions on that one? Okay. All right, now we worked on these the other day as well. And 3 to the 4th power is 81. Number 23, the opposite of 2 to the 4th. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. The opposite of that is a negative 16. This one, 3 to the 3rd, and then negative 4 to the 3rd. So 3 times 3 is 9. 3 times 9 is 27. 4 times 4 is 16. 16 times 4 is 64. Okay, this is a negative to an odd number, so your answer is going to be a negative. Now, it doesn't matter exactly where you put that negative symbol. It can be out to the side or up at the top or the bottom or whatever, but the whole thing is a negative. Okay, a negative raised to an odd power is a negative. All right, on this one, you have your dividing, so you've got 5 to the 5th over 5 squared, which is 5 minus 2 is 3. So 5 to the 3rd is 125. Either one of these answers would be considered okay. Because sometimes they want the actual number, other times they just want it like this. Okay, and this one is 5 squared times 5 to the 1. If it's just a 5, there's really a 1 there. So if your base is the same, you add your exponent. So this is okay for the answer. That one is also okay for the answer. Now, this is a -5 to an odd power, so you know it's going to be a negative. 5 times 5 is 25. 25 times 5 is 125. And, of course, you can also use your calculator. Okay, this is 4 squared raised to the 3rd power. When you have a power of a power, you multiply them. So 2 times 3 is 6. 4 to the 6th is okay for your answer, and so is this. Okay, usually if it doesn't tell you, look in the back of the book and see what form they want it in. This particular one, 3 to the -3, you bring it down into the denominator and it makes it a positive. So that's 1 over 3 to the 3rd, which does give you a 1 over 27. Okay, questions on that? Did everybody get them okay? Okay, good. All right. Okay, now we have, let's see, one more page in this set of papers here, and that is working with scientific notation. Okay, so, okay, this is on 5-7 in the book, which is, let's see, okay, now we're not going to do everything that's in, 5-7. Let's see, wait a minute.
There's something notations in 5-6.
Yeah. Mm-hmm. That's what I was going to say. No, that's not 5-7. Okay. All right. Scientific notation is on page 260, 261. Scientific notation. Okay. Now, scientific notation is just a way to write a large number, an easier method. So we've got something like this. Okay, and you will see scientific notation a lot in newspaper articles and things like that. And so what you want to make this a number between 1 and 10. This is scientific notation. Okay. And so you want to take this huge number and make it some number between 1 and 10 and make it easier to talk about and everything. So what you do, in any whole number, your decimal is right there, right? At the end. Even though it's not on there, you know that that's where it is. Okay. We want to move this decimal and make this a number between 1 and 10. So we would move it 3, 6, 7 places and put it right there. Okay. So that's 9.3 times 10 to the 7th power. Okay. 9.3 times 10 to the 7th power. Okay, so we're taking a large number and making it into a smaller number. Okay, let's do another one. Let's say we have 876. Okay, we have that number right there, and we want to write it in scientific notation. Okay, so we're going to take the decimal, which is right here. Where are we going to put it? In between which two numbers over here?
Between the 8 and the 7?
Good, in between the 8 and the 7. So we're going to move it 3, 6, 9, 10, 11 places and put it right there. Okay? So that would be 8.76 times 10 to the 3, 6, 9, 10, 11 places. Okay. Now, like if you're reading something in the newspaper, you know, they might have the number written like this. Okay, so you could figure out what this is by multiplying it times 10 to the 11th or just moving it 11 places. Okay, so you can have it this way and make it big, or you can have it big and make it small. Okay, now suppose we have a number like this. Okay, this is a tiny number. Okay, it is a fraction of a whole number. As remember, we did where we had to write different numbers like this, and we talked about that this is tenths, and this is hundredths, and this is ones, tens, hundreds, and then the decimal was in the middle, you know, like for and. So everything back this way is a fraction of a whole number. Okay, so this is a tiny number, but we can also use scientific notation to read this. It would be real hard to say tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, okay, and read it that way, you know, 23 billions. But we can move the decimal, make it a number between 1 and 10, so we're going to move it right there. So that's 1, 2, 3, 4, 5, 6, 7, 8 places. So it will now be 2.3 times 10 to the 8th, but it's going to be a negative 8. Okay? And this is real easy to remember. If your exponent is a positive number, it's a big number. If it's a negative number, it's a little tiny fraction of a number. So you can take it like this and write it that way. Okay, big long number like this, or you can take a tiny, tiny number and write it like this. So if you were changing it, you would know that would have to go to the left. Okay, now look on page 260. There are some problems right here. It says some examples of numbers in scientific notation are 3.7 times 10 to the third, 2.05 times 10 to the negative 3, and so forth and so on. Okay, so down here it gives you a procedure for moving the decimal, which we've talked about. Now, let's look on the top of page 261, and number 1 says, write each number in scientific notation. So this is A. All right, it says, the population of the United States was 288 million, and so we want to move the decimal into 2.88 times 10 to the 3, 6, 7, 8 places. Okay, all right, and we can check, and if you try to do these without, you know, looking at them, all right, look at number D. Don't look at the answer. Okay. But look at that. I mean, that's hard to even figure out how many zeros that is. Okay, but it would be a 1.1 times 10 to the negative something. And so we've got to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the negative 12. 1.1 times 10 to the negative 12. It's just an easier way of writing large numbers. Now, so at the top, you're taking the decimal notation and making it in scientific notation. Now at the bottom, you're taking scientific notation and making it just a normal number or decimal notation. So if you have 9.3, which is the first example, A, 9.3 times 10 to the 7th, okay, which direction would you move your decimal? To the right. It's a positive number. It's going to be big. Okay, so 1, 2, 3, 4, 5, 6, 7. And then just fill in your zeros, okay? And then rewrite your number or erase it, whatever. Okay, so there would be your number. If you've got 4.5 times 10 to the 9th, So you put 4.5. It's a positive one, so you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Another thing that's easier to do is to move it like 3 at a time, 3, then 6, 9, like that. But anyway, so you just put in your zeros and then rewrite your number, and you've got it. Okay, then on the C part, we have 1.35 times 10 to the negative 3. All right, so 1.35, it's a negative, so this means it's going to be a tiny number, so we're going to go 1, 2, 3. So 0.00135 would be that one. So all you're doing, you're taking a large number and rewriting it in an easier form, okay, or a very tiny number and rewriting it in a better form. And then you're taking the actual scientific notation, making it back into a number, okay, so forth, so on. But one way to think of it too, if it's a positive number, you go to the right. If it's a negative number, you go to the left. But I usually think of it, if it's a positive number, it's a big number, okay? Positive exponent's a big number. Negative exponent is going to be a fractional part of a number, okay? Now, look at on page 9. Okay, this one right here. Okay, all right. Do this page. Okay, write in scientific notation. Okay, I'll help you with the first one. It's so little. All right, you've got 240. Okay, and to be written in scientific notation, it has to be a number between 1 and 10. So the decimal would go right there. How many places did I move it? 2. So 2.4 times 10 squared. Okay, check it. Yeah, that would be 240. Okay, so 2.4 times 10 squared would be your first one. Okay, so try those.
Can I ask you a question?
Uh-huh.
When you say it has to be like a 1 or a 10, what do you mean by that exactly? You talking about in the 1s or 10s?
A number between 1 and 10.
Oh, okay, gotcha.
So instead of making that 240, you make it 2.4.
Okay, gotcha.
If you can see, the most common mistake is people would say 24 times 10 to the something, but see, 24 is not between 1 and 10.
Yeah, gotcha.
Okay.
And it could be 0. It could be 0 either, right?
Right. can check, see how you did. 2.4 times 10 squared. Number 2, 5.3 times 10 to the third. 3, 1.25 times 10 to the fifth. 4, 4.3 times 10 to the sixth. 5, 7.392 times 10 squared. Number 6, 2.31 times 10 to the negative 1. And if you missed this one, you may have put it here, but that's a 23. It's got to be a 2. Number 7, make it 2.345 times 10 to the negative 4. You moved it 1, 2, 3, 4. Okay, this one, 1, 2, 3. 1.2 times 10 to the negative 3. This one, make it a 9, and you moved it negative 8 times. These are all small numbers, less than 1. So that's why you have negative exponent. Now, a lot of people will miss these because they'll make it 23.45, or they'll make this one 12 or something like that. But it has to be a number between 1 and 10. Okay, then you're going backwards. So it's 4.1 to the negative 3. So you take this and move it 1, 2, 3 backwards. So 0.0041. This one, 3,014, 200. This one, 48,590,000. This one is a negative, so you go backwards 0.0004. Okay, how'd you do?
So number 9, that's will be negative 8.
1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's a negative 8. Because it has to go behind the 9.
Oh,
Yeah.
Oh,
Mm-hmm.
okay.
Can you show me number 5?
Okay. Move it 2 places over here. Make it a 7. Because 7 is between 1 and 10. So 7.392, and I moved it 2 places. It looks easy until you start doing it, and then you think, Okay. Main thing you have to remember is that if it's a number bigger than 1, it's a whole number, a big number, you got a positive exponent. If it's a fractional part of a number, it's a negative. Let's see, if you have a number like you see how this is your and, everything over here is a decimal or a fraction. It's small. Everything over here is big. Okay.
So that would, we would do 3.2.
That one we're not changing. I'm just showing you any number, big number. This side are fractions. This side, they're whole numbers or big numbers.
How would we do something like that?
Okay. You would have to move it to here. 3.200 blah 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 blah. Okay. But we won't have one like that. Okay.
All right, and I have one more question. So like on the point, like for instance, number 7, where it says 0.0023. So there's kind of you kind of want to put like an imaginary 0 to the left of the decimal, and that count as a space there. Is that how that works? Because my problem is I put 2.345 times 10 to the third power, and I should have put fourth.
Okay.
So I should have imagined knocking 0 over
Say
on the left side.
1, 2, 3, 4.
Okay.
Okay. It's got to make it a number that's between 1 and 10. Okay. If you have let's see. Okay. Okay. You're going to put it right there because that's a 3.64. 3 is in between 1 and 10. Then you've got to move it 3, 6, 7, 8 places. Okay. Most people get the positive numbers better than they do something like this. Okay. But if you just cover that up, you just got to go right there to make it a 7. Okay.
And so that 7's one of the spaces.
1, 2, 3, 4, 5, 6, 7.
Gotcha.
Mm-hmm.
That's my wrong. Whenever I was doing the times,
Uh-huh.
I wasn't counting that 7. I wasn't counting the 7.
Right. Okay. That's, I mean, the mistakes that you're making are normal. That's just the way it goes.
It's not weird.
Okay. Now, what we're going to do to review this on page 264, we're going to do 13 through 40. Wait a minute. Through 75 odds. 13 through 75 odds. Okay. Now, this will review those rules of your exponents as well as scientific notation. Okay. And you may want to keep on page 260, there's the summary of all the rules of exponents. There's one thing that we didn't talk about this week. Anyway, anything to the 0 power is equal to a 1. Just remember that. Anything to a 0 power is equal to a 1. Okay, so work on those and check your answers in the back. Okay, then if you have questions, then let me know.
Oh, we have done 13 to 43 already. Now we continue the rest, right?
Mm-hmm. Yeah, to start at 13. Mm-hmm. And go all the way to 75. It looks like a lot, but they're easy. Short.
we'll start to the back when we're doing to see how we did, or
Mm-hmm. Please do. Yeah, any questions, let me know, I'll help you.
only missed two.
Okay.
I'll figure out why. Yeah, I see one now.
Okay.
I'll go use your restroom real quick while they're finishing up.
Mhm. Okay, any questions y'all have on that? Okay. All right, later we'll review a little bit more on those things, but what we're going to do right now is notes on chapter 6, which is algebra, which we've already been doing algebra. But anyway, we're going to add some more to that. And the first part is on the order of operations, which we've already reviewed that today. The next thing is open sentences. Okay, an open sentence means that the sentence contains a variable. Okay, the sentence contains a variable. Okay, a variable is something like a X or a Z or a P or Q or something like that, and they can vary as to what they equal. So if we have something like this, an X plus 7 equals 12, that is an open sentence. Okay, it has a variable in it and it makes a complete thought or a sentence. Okay, if it has an equal sign in it, it's an equation. One side is equal to the other. If it has a less than or greater than or equal to or something like that in it, then it is an inequality. Okay, it's unequal. One side is more than the other, or one side is less than the other. So those are inequalities. Okay. All right, next, if you have something like 2x or 2 times x, or written like this or like this, all of these mean to multiply. Okay, so with open sentences, they will have a variable in them, like a P or a Q or an X or a Z or something like that. It can vary depending on what the variable is equal to. This is an example of an open sentence. Okay, if it has an equal sign, this side is equal to that side. If it has a greater than or less than, whatever, one side's bigger than the other. If you have a 2 right next to an X, that means multiply 2 times whatever X is. It can also be written like this. It can be turned around or like that. This is the most common way that 2x is written. Usually your number first and then your variable. Okay, the next thing we have is combining like terms. These are terms that are like each other. If you have a 4x plus a 2x, you're going to get a 6x. Okay. It's like if you have 4 bananas plus 2 bananas, you're going to get 6 bananas. If you have 4 apples plus 3 bananas, you're just going to get a bunch of fruit. Okay? You can't combine those because they're not alike. Okay, so that's what we mean by like terms. They have to be exactly the same. If you have something like 8y plus 2y, you're going to get 10y. Okay? If you have a negative 3x plus a 4x, what will you get? An x. Okay, good. All right, if we have something like 2 times 3x, okay, multiply your whole numbers, and there's nothing to multiply the x by, so we get a 6x. Okay, so 2 times 3x is 6x. Okay, if you have something like a 4 times a negative 2a, 4 times negative 2a, negative 8a. Okay, now I'm trying not to put equal signs in here because these are not equations. Okay, I did put one up there. But anyway, you're combining them and that's going to be your answer. Now, if you have something, like I said, like a 4x plus a 2y, You can't combine those. They're not the same. Okay. Now, we're going to, I have these listed wrong. We're going to work these problems, but this is set 2, so we don't do it first. We're going to do set 1 first. It's over on the back, and do 1 through 14. And I'll hand it to you the way that it goes. Okay, this is just combining like terms. It won't take long to do 1 through 14.
So do not put an equal.
Okay. Yeah, on these, just put the answer and circle it. Mhm. Can any of you take this to Bobby? Does he live over here, or where's he live? Okay. Could you get this to him?
Yes. Right now?
Thank you. No, just later. Thank you.
You said it's 1 through 14 or the whole?
No, just 1 through 14. Mm-hmm.
Sorry.
Number 8 is dividing, right?
Yes. Mm-hmm. Check our answers, see what we got. Okay. Alright, number 1, 2x plus 3x is 5x. Number 2, 6y plus 3y is 9y. 3, 2x plus an x is 3x. 4, 5x minus 3x is 2x. 3y minus y is 2y. 4z minus 2z is 2z. 2 times 7y is 14y. Number 8, 6z divided by 3 is 2z. Number 9, 2 we're going to 4 2 times, so that's a 2x. 3 we're going to 12 4 times, so that's a 4z. This one you have 2y plus 3y, that's 5y plus 2. This one, 6z minus 4z is 2z plus 4. 13, 4y minus a y is a 3y, and then a negative 2 and a 3 is a 1. So 3y plus 1 is your answer on that one. On this one, you had to find your like terms. These were alike, and those were alike. Okay, over here, you got 6z minus a z is a 5z, and then a positive 2 and a negative 3 is a 1. Now you're using all kind of properties there to get to this. You're like switching these around, so that's the community property, putting them together, and then you're regrouping, which is the associative property. But when we're doing them, we're just find the things that are alike and add them together. Okay, questions? Okay, okay. All right, go ahead and take about a 10-minute break, and then we'll, or 5, or whatever you want to take, and then we'll come back.
See your son.
That's what I was gonna say.
Yeah,
They're over there with your family right now, aren't they?
They are in front right now.
Okay, good.
It's the latest for
Very good. Yeah, I've been keeping up with him, but I hadn't seen anything from here yet. Yeah. What is his name, Joshua?
yes.
Right.
And where's Jamie? Jamie is here.
I see. It's neat, isn't it?
Yeah.
It is amazing what technology has done to mission work.
Yeah.
Because when Wayne first started going, I wouldn't talk to him for like 3 weeks, you know,
Yeah.
and it would only be when he came back to Singapore. Singapore would be the base, and then he would go to India and then come back. Because a phone call was like $7 or $8 a minute.
Yeah.
You know, if you wrote a letter, it'd take about 3 weeks
Yeah.
to get here. But now it's instant.
Yeah.
That's great. Thanks for showing me. It makes you feel funny, doesn't it, that you're over here and they're over there.
Yes, and this morning at around 4 a.m. we got a call from Vietnam
Oh.
about this event.
Yes, that's another thing. Oh, man, yeah. I have to be careful who I'm friends with over there.
Yeah.
Because in an average day, I'm talking to about 5 people from Burma, a couple from the Philippines, and some from India. The India people don't contact me as much as the ones from Burma. It's just constant all the time.
Yeah.
But it's funny. But it has really helped a whole lot because we were doing our newsletter. We put out a newsletter each quarter.
Yeah.
And so we were doing July, August, and September. And so there would be a picture of Jeremy come through, and so I'll put it in the newsletter, and then one from the Philippines, I'll put it in there, and then, we can get it out. It's really something, how it's changed.
Yeah.
Makes my life much easier. have donuts if you want one.
Oh, yeah.
Down there.
Thank you.
I don't need it, but I want it. I warmed it up in the microwave, so it's wonderful. Krispy Kreme donuts are the best. Especially if you get them when they're hot, you know.
Yeah.
So I just warm this up a couple of seconds. Perfect. Well, the warm weather is hanging around a long time.
Yeah.
That's good for you.
Yeah.
It's supposed to be real nice. We're going to Gatlinburg for the honeymoon.
Okay, that's good.
It's
I
supposed to be
wondered.
real nice up there that time.
Yeah, that's what I. Supposed to be pretty good. I think this week it's supposed to get cooler and less humidity at the end of the week, but not cold or anything.
Yeah. It'll be real nice up in the mountains. We were going to go to St. Augustine, but we ended up buying a house, and so we found it from financial reasons. We changed our plans. Decided to go to the mountains.
Where'd you get your house? Is it in Marco?
It's in Tuscumbia. Yeah. There's a little community right behind Shoals Church,
Yeah.
and it's just started a few years ago, and so we just bought one of those little lots. And
That's good. I had my husband had an aunt and uncle that lived over in that area.
we were real fortunate. We the house appraised for $30,000 more than what we bought it for.
Oh.
So we basically made money off of it.
Yes, that's good. When you get ready to sell it,
Yeah,
it'll help.
yeah. And there's other nicer houses that are being built around it, which will help, help things work.
Sure does. I wanted to kind of tell you what we're in store for. I changed things around just a little bit, but we finished chapter 5, and then today in chapter 6, and then we'll finish chapter 6 next week. Then we'll have the fall break, and then we'll have the test here, and we'll probably finish 6 before then. I'm not sure, but anyway, I decided to do it that way, so you won't miss anything. And then also geometry will be the next week, and then you will be out for 2 weeks. One is like fall break, and then I'm going to be gone for a week, so you get a couple of weeks off, and then we'll come back and just have 2 chapters, and then we'll be through. But anyway, just kind of wanted you to know that. But I think the test will still be, around the 31st.
November 28th. That will be a Vietnam forum. So can I be absent in this class and be in the on
Okay, I'm trying to figure out when that starts. If that's in the afternoon or the morning.
The
Do
morning,
you know the morning?
morning, the whole day.
Okay, all right, okay. Yeah, if that is when it is, we'll have to change things, which I'm sure you won't mind. If we we go.
I won't argue with you.
Anyway, right. Okay, thanks for reminding me about that. Okay, let's see. Next thing is solving expressions. So back to notes again. Okay. Now, if you have something like this, 3x plus y, and you have that x is equal to 3, y is equal to negative 2, and z is equal to 5, and we're going to substitute these numbers in there and figure out what this expression is worth. Now this one has 2 variables in it. So in place of the x, we put in a 3, and then in place of the y, we put in a negative 2. Now, most of the time, if I think of it, I always put it in parentheses so that I won't get mixed up, okay? Because this means 3 times whatever x is. So if x is 3, that's a 9, and then plus a negative 2, which gives you a 7. So all you're doing, they'll give you what x, y, and z is equal to, and then you stick it in and then find your answer. Okay? If we have something like this one, 5xy plus 2 times y minus z. 5xy plus 2 times y minus z. Okay, so in place of x, I'm going to put a 3. In place of y, I'm going to put a negative 2. Plus 2. And then here, in place of that y, I'm going to change that into another set of braces. Okay, and then I'm going to put a 5 right there. Now, you don't have to change it that way. You can use 2 sets of parentheses if you want to, but just be careful when you're substituting numbers in. Okay, now we have to do what is in the innermost grouping symbol first, so that means we've got to do that. So we'll write this stuff down. Okay, and we have to do what's in here. So this is a negative 2 minus 5, which gives you a negative 7. Okay, now, once we've done what is in the innermost grouping symbol, we have please, excuse, no exponents, my dear. So multiplication or division, whichever one comes first from left to right. So we start over here. 5 times 3 is 15, times negative 2 is negative 30. Plus, and then we've got some multiplication here. 2 times negative 7 is negative 14. Okay, so I went left to right. And then I still had adding here in the middle, and then I had multiplying over here, and then now I can add them together, so like a negative 44 would be our answer there. Questions on that? Okay, now what happens is we're going through about 6 weeks or so of Algebra 1 here in one day, so, you know. So if things are getting too fast, let me know. Okay, next is solving equations. Now an equation, remember, has an equal sign in it. Okay, it's equated. One side is equal to the other. Now there are basically 4 types of equations. One is like this, x plus 2 equals 6. The next one is like this, x minus 3 equals 9. The third type is like 2x equals 10. The fourth type is like 1/2 x equals 12. I'll give you a minute to get that written down. Okay, now these are like 4 little simple types of equations. Now everybody in here can give you the answer without doing anything on paper. But with algebra, if you learn how to do the simple ones, when you get to a hard one, it won't be hard to do if you have learned how to do each individual little problem. Now I'll show you what I mean. We could have something like 1/2 x minus 10 equals 4 times x minus 8, or something like that. See, that looks horrible. Okay. But if you learn how to do each individual part, it's not hard, and you don't have to do that one. Okay. Anyway, I just wanted to show you why you need to learn each little part. Okay, now this one is x plus 2 equals 6. We all know that that is what? A 4. Okay. But what we do on this is we do the opposite. This is adding 2, so we are going to do the opposite, or subtract 2 from both sides. Now, depending on who taught you algebra, which type of book they were using, they may do this underneath it. They may do like this, x plus 2 equals 6. They may have made you rewrite it like this and put it out to the side. They may have made you move it and change the sign, and that'd be a 6 minus a 2. Okay. Now, that's the way I learned how to do it. Most of you, I don't know, but I know you learned it that way, didn't you? Okay. All right. Most people, though, about your age, did it this way.
That's a new.
Right. You do it however you know how to do it. Okay? I don't care which way, as long as you know what you're doing. Now, if you're missing every one of them, you're going to have to do it the way I tell you to. Okay? But anyway, some people put a separate step down here. Some move it across the equal sign. It changes the sign. I don't care. Okay? But anyway, this part cancels out. Right? Positive 2, negative 2 is 0. That's what you want. You want your x on one side by itself. Everything else on the other. 6 minus 2 is 4. Okay, and you say, well, I can figure that out. I know you can. But I never will forget, I had a little boy in Algebra 1 who was in the 9th grade. He'd always made straight A's, brilliant. Okay, he would not listen to me. And so when the problems got about that long, like that, first one up there, he was crying. He turned bright red. He was about ready, to freak out. And so we had to go back and learn each individual little step, And then he made good grades again. But don't want anybody freaking out on me. Okay.
So why is it that we put the negative 2 there? I can't remember.
Okay. You want your variable by itself,
Okay.
so you want to move this.
Okay.
You can move it by moving it over and changing the sign, make it a negative 2. Or you can do the opposite and add a negative 2 to both sides. Okay, so that makes that a 0. And you have x equals whatever the answer is. You're trying to get x on one side and everything else on the other. Okay, now on this one, if this is a subtracting 3, what should you do to each side? Add a 3. So x is 12. If you do it the way On does it, this moves it over here and makes it a plus 3, so 9 and 3 is 12. Okay, but I know everybody in here can figure out what the answer is without doing all that. Okay, this one, 2 times x equals 10. So we do the opposite, or we divide by 2. So that gives you an x, and this gives you a 5. Check it. 2 times 5 does equal 10. That's the good thing about equations, is that you can check every single one of them and know if you have your answer right or not, if you take the time. Now, this problem will cause more people to miss it than any other kind. But half of something gives you 12. What's x going to be? 24. Okay. All right. Now, but what you do when you have one like this is a fraction. To remove that fraction, we're going to use the reciprocal, or turn it upside down and multiply both sides. Okay? Because all that will cancel out and you'll have an x, and 2 times 12 is 24. Check it, half of 24 does give you a 12. Okay. Now, so your whole goal on an equation is to get x equal something. So you want to remove whatever is on the side with the x. If it's adding, you do the opposite or you subtract. If it's subtracting, you do the opposite or you add. If it's multiplying, you do the opposite or divide. If it is dividing, you do the opposite or multiply by the reciprocal. Okay, so that's what you're doing there.
So just to clarify, so with equations, we're trying to figure out what the variable is.
Yes.
And then with expressions, do they usually give you what the variable is with expressions, and you just work it out?
Yeah. Good. Okay, now, the next type of equation, they put like this one and this one together, or this one and this one together. And so every equation after this is a combination of one of these 4 types of equations. Okay, let me give you an example. This next type is called an AX plus B equals C type of equation. You don't have to remember that, but I'm just showing you so you figure out what kind it is. It's this, 2x plus 1 equals to 17. Okay, now, that took, this type of equation right here and that one and put them together. See, it's got a 2 times x and then a plus 1. Okay, now, so what happens is we can this is attached, this 2 is attached to this variable. So this is what we need to move by doing the opposite. It's a +1, so we're going to subtract 1 or move it across. What's left is this. Okay. And then this turned into this type of equation, which you already know how to work. Divide 2 into both sides. So we divide 2 into 2, so x is 8. Now you can check it. Half of 8 is 4 plus 1, wait a minute, excuse me, down here. Okay, 2 times 8 is 16 plus 1 does give you 17. So you can check every equation by putting it back in the problem and seeing if it works. Okay, so the problems that you're working are a combination of those first 4 types of equations. Okay, now let's look at this one. Let's say we have 1/3 x minus 7 equals 8. It's still the same type as this, except you have a fraction and you have a minus 7. So that one is using this equation and that one and putting them together. Okay, now so you put this one is attached to this x, so we don't bother it yet, but we're going to move the 7. Okay, raise your hand if you know how to move the 7 or get rid of the 7. Okay, so we add 7. Some people add it up here, some do it down underneath. I don't care how. All right, but anyway, a -7 to +7 is 0, so it's gone. And then 8 and 7 is 15. Now, this is 1 divided by 3, so you do the opposite or you multiply both sides by the reciprocal. Reason you do that is you want to remove that. So you want an x over here. And this is a 45. Okay, so 1/3 of 45 does give me 15. Okay, so 1/3 of 45, okay, is 15 minus 7 gives you an 8. So you can always put this back in here and see if it works. So what you have in this lesson, you have 4 types of equations. X plus something equals a number. X minus something equals a number. Multiplying 2 times something gives you 10. Or dividing. So you always do the opposite of whatever it is. Then you can combine different types of equations and they end up, you know, looking like that. They're big, big numbers. Okay, I want you to do this one, just somewhere on your notes. 1/2 x minus 3 equals 12. 1/2 x minus 3 equals 12, and tell me what you get.
X equals 30.
Good. Okay. So you add a 3 to both sides first. So 1/2 of x equals 15. Some people will make a mistake and get the wrong answer on here. But you got to multiply by the reciprocal. So that's a 30. So 1/2 of 30 is 15 minus 3 does give you a 12. So if you take the time, if you've got a test, just put your answer back in there and see if you get it right. Okay. Let's see. All right, do this one. 2x plus 1 equals 8. 2x plus 1 equals 8. You get a fraction? Okay. So if you subtract 1, 2x equals 7. This is multiplying, do the opposite or divide. So you get a 3.5. Okay.
That's what I got with it. I'm trying to like make sense.
Mhm.
So 2.67. The only thing is like that doesn't make sense like logic. Unless I'm just missing something.
This
Like
is
three-
like 2 times, if you're checking it, 2 times 3.5 plus 1 equals 8. Okay, so that's 2 times 7/2 plus 1 equals 8. Those cancel, so 7 plus 1 is 8. Okay, so it does make a true statement
Okay.
on there. Okay. Now, and this is why you have to learn each little step, because when you've got fractions in there, you can't do that in your head unless you're a genius.
Well,
Okay.
definitely not.
Now, next thing, we have to remember our distributive property and how we're going to use it in an equation. Okay, distributive property. 2 times x plus 1. Okay, now, the distributive property says to take the outside one times the first one plus the outside times the second. So to simplify this, that would be a 2x plus 2. 2 times x is 2x plus 2 times 1 is 2. We're using the distributive property to make it a simpler problem. Okay, if you have one over here, 4 times y minus 2. Okay, you use the distributive property and get an answer, and then we'll check it. Okay, 4 times y is 4y, plus 4 times negative 2 is negative 8. This can also be written like that. It means the same thing. Plus a negative is the same thing as a negative. I always say outside times the first plus outside times the second, so that I don't make any mistakes with my negatives. And I'll show you why. If you had a negative 2 times a y minus 3, okay, this gives you a negative 2y plus negative 2 times negative 3, positive 6. Okay, it just keeps it, if you do outside times the first plus outside times the second, it can keep you from making some mistakes. Now, back to our equations. Okay, let's say we have this one. 2 times x plus 2 equals 4 times x minus 1. You see why you need to know each individual little step? That's practically impossible to figure out what x is unless you know all these different steps. Okay, so distributive property, 2 times x is 2x, plus what goes here? What?
Say 4.
4. Good. Over here, 4x plus
4.
negative 4. Unlike signs are negative when you're multiplying. Now, this is a totally new kind. We have variables on both sides and we have numbers on both sides. We want to get all of our x's on one side, all of our numbers on the other. So what I usually do is move my smaller number of variables so that I'll end up with a positive x. Other people like to keep their x on the left-hand side. You do it however you want to do it. Okay, but here's 2x and there's 4x. So I want to move these by subtracting 2 from each side. Or like On does it, he moves this over here and makes it a negative 2x. That's gone now. So I have a 4 equals a 2x plus negative 4. Now, this equation is one of those ax plus b equals c type of equations. These two are together plus a number equals another number. So, You already know how to work this problem. Raise your hand if you know what to do to both sides. Okay. You add a 4. Okay? Because remember, we want our variable on one side by itself, and we want this over on the other side. Okay, now we've got 2x equals 8. If you don't like the way that looks, you can turn it around that way. If you like your variable on the left-hand side, just switch the whole thing around. But anyway, so we've got 2 times x, so we did the opposite, or divide by 2. Okay, now you can check it. 4 plus 2 is 6. 2 times 6 is 12. Okay, 4 minus 1 is 3. 3 times 4 is 12. So 12 equals 12. So you do have the right answer. Questions?
Instead of divide for 2, can we move 2 across the equal?
You can make it a negative 2x if you want to. Right here. You're talking about moving that
no.
over there?
No, there's a 2 times x and equal 8, right?
Right here.
Yeah, right there. Can we move the 2 over the...
You can just switch it all around.
Yes,
And put your 2x on this side and your 8 on the other. But it wouldn't change the sign if you just move the whole thing like that.
Yes.
Okay. Because some people like to keep their x on the left.
Yes, I got it. But instead of, because you add in 2, so 8 divide 2, 4. But instead of adding 2 to divide, then just move 2 across the equal, just like the way that we subtract. Yeah, can we do that?
But can't subtract it because this is multiplying
Yeah.
right here.
So we cannot move the multiply.
Because if you're multiplying, you have to do the opposite, which is divide.
Okay.
By 2. Good question.
Alright, so with that problem that we just did, we subtracted by 2 on the top there. So we're just trying to find a number that both of them go into. Is that what's going on there? Or
Now what you're doing is trying to get them on the same side.
yeah.
Okay, here's a 2x and there's a 4x. So I'm taking my smaller one
Okay.
and I'm subtracting it from both sides. 'Cause the way that they taught you to do algebra is you keep the equation balanced. And so whatever you do to one side, you do to the other. So if I take 2x away from here, it's gone. And then I took 2x away from there and I got 2 here. Okay. Now, work on this one. Now this one, we've already done the distributive property part of it. Wait a minute. Okay. See if you can get that one to work out. Okay, so take 4x from both sides, or as On does his, and I used to do mine. Move it over here, and so it's gone. So you got a 2, 6x minus 4 is a 2x minus 3. Then add a 3 to both sides. So 5 equals 2x. Are we the same here? Divide by 2, so x is 2.5 or 5/2. Okay. Now, and you see how some of these, it's real hard to get the right answer or even to check it. Okay, here's another one. 8x plus 6 equals 3x minus 9. Okay, so subtract 3x from both sides. 5x plus 6 equals negative 9. Okay, raise your hand if you did that part. Got this part. 5x plus 6 equals negative 9. Okay, then we add and, well, let's see. Subtract a 6. Now, here's where you might have a problem. Negative 9 minus 6 is negative 15. Divide through by 5, so x is negative 3. Okay, get it? Okay, good. All right, now, next thing you do, okay, on your worksheet, turn it over on the other side and do set 2, okay, which is 1 through 28. Now, before we do that, I better show you one. That's like down at 27 and 28, we have not had a fraction written like that. Look at number 27. This is x over 3 equals a 5. Okay. Now, this is the same thing as 1/3 x equals 5. Okay. X divided by 3 is the same thing as 1/3 of an x. So if it was like this, you would multiply by 3 over 1. So that's a 15. Okay? You can also think of that as multiplying by 3 over 1 right here. Okay? Either way, it cancels it and you have an x. Okay? But I hadn't showed you that. Okay, do 1 through 28 on set 2. It starts off simple and then it keeps on going. Now there's one thing, there's another thing I forgot to tell you. You've got some greater than or less than symbols in there, like number 10. Number 10 is x plus 2 is less than 7. Okay, you work these exactly the same way that you do an equation. You subtract a 2, so x is less than 5. Anything less than 5 would work out. If you did a 4, 4 plus 2 is 6, that's less than 7. If I did a 1, 1 plus 2 is 3, 3 is less than 7. The only thing that is different on these, I don't think there's any on this page, but if you multiply or divide by a negative number, you must change the sign in the opposite direction. Sorry, I didn't do this. That means if you've got a negative 2x is greater than 6. Here's an example of this. Okay. In order to solve this, I would have to divide by a negative 2, and that would give me a negative 3, would be my answer. Anything bigger than negative 3. So, what you have to do, if you try that, a number that's bigger than negative 3 is a 5. So if I did negative 2 times 5, that would give me a 10. Let's see, wait a minute. Okay. is greater than -3, and that would make it a false statement. So what you have to do, if you divide through by a negative, you have to switch the sign around the other direction in order to get the right answer. And you think, well, who in the world came up with that? I don't know. But they figured it out. If you left it the same way, you'd get a wrong answer, because say -10 is greater than -3, which is a false statement. So if you multiply or divide by negative, you got to change the sign. Okay, so put that in your notes somewhere, and then do that 1 through 28, and then we'll check the answers to those in just a second. I don't know if there's any even on this sheet that are like that or not. I don't think so.
number 15, how can we do it? Because it's
Okay.
X and 4.
Right.
We just,
All you can do is, it says find the solution set, so you could answer that in words. What would be some of the answers?
that will be 3. Yeah.
Right.
Just
Keep
write
going
down.
down.
Yeah.
Put in on this one, oops.
Easy mess.
same thing, but this one
So
maybe.
it means anything bigger than 1 will work. 2 plus 4 is 6, is bigger than 5.
Oh, okay. So when I put it here, so this means
Mhm.
5
Mhm.
and it's greater than 5. It
Mhm.
make no sense, so
Right.
I'm confused.
Right.
Okay, so it's the same thing.
Okay, there's a couple of these I wanted to work. Let's see. Anything before, like number 22, that you need to see worked? Okay, well, I want to show you 22. 3z minus 1 equals 2z. Now, there's several different ways to do this, but it's confusing because you've got z's on both sides, but you don't have numbers. Okay, so if I subtract 3 z's from both sides, I get a negative 1 equals a negative z. I can do it that way. Other people might do it like this. If they took 2z away, you would have a z minus 1 equals 0. Either one, you're going to end up with the same answer. Add a 1, so z is equal to 1. Over here, if they're both negative and you divide through by a negative 1, you're going to get a positive 1 for the answer. Some of you may have done it this way, some may have done it that way.
I did it,
Oh, that's a 3G. I thought that 32. So.
Oh, okay. Yeah, I know. I tried to fix some of them, but I didn't get them all fixed. Okay.
No wonder why it's.
Okay. All right, on 24, you've got a 3y minus 6 equals a 2y. Same thing. If you subtract 3 y's, you end up with a negative 6 equals a negative 1y. So both will be positive. You may have done it the other way. You may have subtracted a 3y or moved it over, and it looked like that. Either way, y is a 6.
this is, I want to make sure I'm doing this okay, because I did it a little bit differently than both of those ways.
Okay.
I did negative, I subtracted 2y from both sides.
Mm-hmm.
So I didn't have anything on the equal side.
Mhm.
And then I had
Okay.
1y, and then that left me with you did the opposite with the 6. So instead of being a negative 6, it left me with a positive 6.
Mm-hmm.
So I said 1y equals a positive 6. So y equals 6.
Right. Yeah, because see, you could take it away, and you end up with 1y minus 6 equals 0. And then move that over there, or add 6 to both
Yeah.
sides. Works out the same way.
Similar.
Mm-hmm. Okay, on 25, you had 4x plus 3 equals 3x plus 5. If you subtract 3x from both sides, you get an x plus 3 equals a 5. Minus 3, x equals 2 on that one. You could also subtract 4x from both sides, and you end up with a negative variable, but it'll still work out that way. Anybody need to see it work that way? I'd be glad to if you need me to. Okay. All right, on 26, you had 5y minus 9 equals 4y plus 2. You can do this several different ways. Excuse me, these are y's. Okay. So if I took 4y away from both sides, I'd have 1y minus 9 equals a 2. Add a 9, y equals 11. Anybody need me to do it where you subtract 5y from both sides? I can do it if you need me to. Okay, 27. We worked that one together. So 28, you've got an x over 5 plus a 3 equals a 5. First thing I would do is subtract a 3 from both sides, so x over 5 equals a 2. Then this is the same thing as 1/5 x, or in other words, you're dividing, so you're going to do the opposite or multiply by 5 over 1. That cancels, so x is equal to 10. 5 on 10, 2 times 2 plus 3 does give you 5. Questions? Okay, alright, good. I'm glad that you got this earlier in your life. Okay. Alright, now the next thing that we're going to do is what's at the bottom of page of this first set. Okay. And if I can find my notes here. Okay. This is, in the book, it's lesson 6.3 and it's on formulas. Okay. This is the whole reason for needing algebra, is working a formula. Okay. Because all sorts of places in life you run into formulas. Okay, one of them is figuring interest. Interest is equal to the principal times the rate times the time. I is interest, P is principal, R is rate, and T is time. Now, you can solve problems with formulas and not even know what in the world you are talking about. And there'll be some in the book that you'll be doing and you won't know what they're talking about. But if you can work algebra, then you can find the answer. Now, it says, suppose that the principal is $1,000, the rate is 6%, and the time is going to be 2 years, 6 months. Okay, and they want to know what the interest would be if you borrowed this particular amount of money and had to pay this back. So all you got to do, P is 1,000, so put it in parentheses. The R is 6%, but what do we need to do to that before we work that in a problem? Change it to a decimal. So that's 0.06. And then the time, 2 years, 6 months, is actually 2.5 years, right? Okay, so all you gotta do is multiply those three things together, use your calculator. You'll want them on this section. So it's $150 that either you pay or that you owe. All right, so there's what you do. All right, now this is one that I use all the time when I'm overseas. If you're trying to figure out what the temperature is, okay, it's like in Vietnam, you probably use Celsius all the time. Okay, so if somebody says it's 40 degrees Celsius, you go, okay, I don't know what that means. Okay, same thing here. If somebody says it's 72, then you Fahrenheit, you've got to figure out, does that mean is that cold or is that warm or whatever? So you can use this formula. So if you want to find the Fahrenheit, if the centigrade is 30 degrees. Okay. So all we have to do is put this in here. And I do this in my head all the time overseas. I just roughly estimate, and then that way I know. Okay, but in place of C, we put 30, okay, plus 32. Then, so 5 going to 36 times. 6 times 9 is 54, plus 32 is 86 degrees. Okay. So you can kind of figure these things out and you'll know what to wear, whether you need a jacket or whether, you know, whatever. Unless you're going to Heritage and you need a jacket all the time. All right, now, let's see. On your worksheet, do 15, this is these right here, 15 through 22. Okay. They're on that set 1, at the bottom of the page, set 1. Okay, just finish that worksheet.
we put a 1 underneath the 30.
Yes. Just make it a fraction. You're working a fraction problem there. And I'm canceling. If you don't want to cancel, just multiply your numerators, multiply your denominators. So you can multiply 9 times 30, 5 times 1 is 5, and then divide that part. But I'm canceling that. One of these comes out a fraction. It's number 20. Okay. In case you're wondering if you got it right or wrong.
200 there. Is that what I'm reading?
Uh-huh.
I don't know. Am I getting any of these right?
Mhm.
14.2. Or am I messing that up? Okay. So that's the Celsius, right? At least.
This one's right.
That's right.
Number 21 P is 200, right?
Yes. After you check them, I'll work whichever ones you need to see worked out. Okay, which ones do you need to see worked?
I got 15 wrong.
Okay. 15. That's like 9/5, 35 plus 32. Okay. Make it a fraction. Cancel. So 63 plus 32 is 95. It's probably in your fraction multiplying right there.
I have no idea how to do 19 or 20.
19.
I'm just lost for some reason.
Okay. Alright. 19. You'll get it. Okay. Let's see. C equals 5 knots times Fahrenheit minus 32. Okay, on 19, when you put in 32 here, what happens? It becomes a 0. So 5 knots times 0 is 0.
Where you at on,
Number 19.
I don't think it's showing on the board. I don't think it's showing up there.
Okay,
Oh, there you go.
sorry.
That's fine.
See, when you use this formula, you may or may not have seen that part where it says use that one right there. Okay. You can also use the other one. It'll work, but it's harder. But when you put 32 in and place the Fahrenheit, that's a 0. So 5 knots times 0 is 0. Okay, and then on 21, no, it's 20. Was it 20 that you needed?
Yeah, 20.
Okay. Alright, same formula. So you've got 5 knots, and you put in a 15 right there, minus 32. Okay? And then that gives you a negative, what, 17?
Yeah, 17.
Okay. Then you can't do any canceling on that one. So this gives you what, 85? 5, 7, 5, 6, 7, 85 over 9, which comes out to the 9 and 4 ninths. But it's a negative because unlike signs are negative when you're dividing. That was weird.
Yeah.
Okay, anything else? Did you have any trouble with 22? 3.5% interest. I move it 2 places. 0.035 is what you used on that one. Okay. All right, now what we're going to do next, rather than go into any new material, we're going to review some on Chapter 5. Okay, so this is the end of Chapter 5 on page 283. Okay, need to work these problems. Start now and then just finish for homework. You know. Don't miss chapel today. everybody get them copied down?
Oh, you should rush me again. That coffee's going out through me.
You what?
Someone rush me again. That coffee's going right through me.
Okay.
Is this chapter 5 3.4 or chapter 5 5.4? Yes, yeah.